Morning, guys. This is my second one trying this 2.2 normal calculations. The first one was 21 minutes long, and I only got halfway through it, and it was an absolute nightmare. It's probably the worst video I've ever put together. And so it's on YouTube. I'm going to erase it after this one. Normal calculations. So let's get to it so this video is not too long. So we're going to talk about what's a standard normal distribution. So as we work with this, the word normal distribution, remember, gives us this shape. That's the key piece. We have to have a normal distribution to deal with these types of calculations. Now, what is the standard normal distribution? It's basically a density curve that has all 100% underneath, and it's related to the z-scores that will come up in the 68, 95, 99.7 rule, because we know the percentages exactly at these points. But on that question the other day about the test score, what happens when it lands right here? How can I figure something out like that? And that's where the standard normal distribution comes in. So there's a couple of places that you can look. I'm going to show you this right here. This is at the top of your classroom. You can print this out if you have the ability to. You can use this on tests. This is the one they actually give you for the AP test. It's got all sorts of formulas and stuff, so you don't have to memorize any formulas in this class. And then the first table is called Table A, and it's called Standard Normal Probabilities, and it has a shape of a graph. This particular one is, if you could, let me focus in. I can't tell if it's focused, guys. Let me stand up. All right. This has all the negative z-scores, so it has all the ones on the left of x bar. So x bar is in the middle here. And then if you flip the page again, it has all the z-scores that are on the right over here. Okay, so this is in the back of your book also. If you flip the back cover open and then flip in about 7 pages or so, it's the first table you come to. The table A is on page T1 and T2, it looks like. So in the very, very back, table T1 and T2 are the ones that you've got to deal with. So that's the standard normal probability. Now, one of the things that you guys got to watch out for is this table only gives you the area to the left. So let's just say like 1 z-score away here. Oh, let me go up a little bit. 2.2 z-scores away. This shaded area right here is 0.0139 or 1.39%. So the key is you got to remember if it's this only gives you the area shaded to the left. There's other tables in here that we'll use later, but this is the main one you need to worry about right now. So let's go ahead and start using this piece here. Oops, I think I took my sheet of paper with it. There it is. All right, so let's look at this. So what we're saying here is that we have a z-score of less than 0.54, and that's your z-score there. And we want the proportion of observations. Proportion can be percent or a decimal, like what I showed you on the graph. And we're going to use the graph right now. So this is a positive z-score. So I'm going to grab the chart that has a positive to it. All right. And I'm going to go ahead and zoom in just a little bit so you guys can kind of see this here. All right. So what we do is, here's our tenths, and this is our 100ths. Okay, so this is the hundredths, and this is our tenths for z-scores. So 1.0 for a z-score. 0.10 for a z-score. 0.11, 0.12, 0.13, 0.14. So like if you go down here, this one here is 1.91 z-score. So this is how we use it. If we want a 0.54, we find our 0.54, And then we find our 4. And so if you look right here, right there, it's 0.7054. Okay? So the proportion under to the left, less than, that's why I shaded it, less than 0.54, this is our z-score, is 0.754 or 70.54% of all the data points or observations. Now, when you do these types of problems, it's easy to make the wrong mistake because of the left-hand, right-hand issue with the graph. I suggest, and I recommend, and I highly, highly would do this because I mark you off on it for tests. If you do not draw this and shade the area that you want, because it actually, you'll mess up, and we'll go over it on this next one. So if we go here, right here like this, I'll squeeze down in here a little bit more so I can make sure it's on there. All right, so good. All right. So if we have greater than, that's a key piece, greater than negative 1.12, we want a z-score. Remember, this is our z-score. Whoa, can't spell again this morning. Friday morning, I've already done this video once or twice. Z-score, negative 1.12, we want the greater than. But I want to bring your attention to the graph. It gives us less than. So we've got to do, there it is, we've got to do something a little different with this. So we know that this whole thing adds up to 1.0 or 100%. So to find this area, we're going to take 100% and subtract the area that's to the left. So we're still going to find the area to the left, but we're going to subtract it off of 100%. So I'm going to find my negative table, go to the negative table, and I got to remember that one, 1.12. Negative 1.12, let's make sure it's centered. We're going to go to 1.1, and then I find my column, 0.02, there it is, 0.1314. Zoom that in for you guys so you guys can see it a little bit. 0.1314 or 13.14%. And that's the answer that I'm 13.14%, and then we subtract it and we get 86.86%. Okay, so that means 86.86% of the observations are greater than a z-score of 1.12. Big concept. If you look at greater than 3.89, you're going to notice that there is no number 3.89. It goes to 3, basically 3.5. Anything over 3.5 is either going to have 0% on that side or 100% on that side. So just make sure that you understand that. Here's the next piece here. We end up having to find the area between the two. So when you're dealing with this, you still find the area to the left. So if I draw, I'm going to draw this out a little differently. So this is going to be 0.49, and we're going to find the area to the left of that. And then this one here is going to, that was a horrible drawing. There's a little chunk in my desk missing. This one here is 1.82, and we're going to find the area for that. When we find the area for the larger one, we're going to subtract it from the smaller one, and that's what I did here. So if you look at 1.82 z-score on your chart, you're going to get 0.9656, and you're going to subtract it from 0.6879, and you're going to get 0.2777, or 27.7%. Same thing with standard deviations here. You go out negative 1.5 standard deviations, 0.5 standard deviations, and you're going to subtract the larger one from the smaller one, and that's going to give you the area that's in between. All right. So let's look at this one here. So if we look at this, yeah, you guys can see it. If we look at this, it asks us for the percentile. The percentile. Well, we know that percentile means 0.850. So they're not giving us a z-score, they're asking us to calculate a z-score, okay? So they're asking us to calculate a z-score. So that means what? That means we got to work from the inside out. So it's 0.85. So we've got to look at our chart here. Know that the negative numbers contain the area for half the chart. Right here. Oops, that's pretty blurry, isn't it? There it goes. For half the chart. And then the positive one starts at 50% and goes to 100%. So if it's over 50, you're going to use the positive side. So I'm going to grab the positive one here. And so now I'm going to start scanning. And sometimes it's just easier to use a piece of paper. So I'm just going to start scanning until I get to the 80s. Oh, there's 80. And I want 0.8023. 0.7995. So which one is closer to 0.8000? This one's closer, 0.7995. So it's 0.84 is what I maybe even did that differently last night. 0.84. I did. I messed that up somehow. Oh, because I'm looking for 85. That's why. Sorry, guys. Let's go to 85. Here it is. 85.08 is the closest one right here. 85.08. So that means that my z-score is 1.04. All right, so we have 1.04. So we go back to this, and we know that it's 1.04 standard deviations above the mean. In a normal distribution, I'm going to ask you this one, and we'll see if you guys get the right answer on there. All right, so let's tackle this here. Lots of calculations all of a sudden. Here we go. We're getting into this. Like I said, this is one of the most, I said it in the other video. I haven't said it yet now. This is probably one of the major pieces or the major piece of statistics. So here we go. So remember, I'm going to write it just above here. To find the probability, you need to have a z-score. And so, score. So you have to, basically one of the ways we write this is the probability that the z-score is either less than and equal to or greater than or equal to, oh man, my desk has bumps all over it, than a z-score, which is x minus x bar over the standard deviation. Okay? If you write it like this and use your calculator, it's going to be even better. So I'll show you here because I kind of set it up for you guys down here. So let's kind of look at our calculations that we need right now. So let's just look at this one right here. So they give us some information. I've underlined it from the last one. There's a lot of extra writing on this. Sorry, guys. All right. And then we got a standard deviation of 6. So if we just use our z-score, this is what it looks like. The z-score of x minus x bar over the standard deviation equals 120 minus 115 over 6. Okay? Now, with that, if you use the chart and do all the math, you end up with a chart that looks like this where we want everything that's going to exceed 120. Well, my x is 120. My x bar is 115 divided by 6, and I get 0.7995%. That means about 20% exceeded 120 miles an hour. Now, do you notice how the way I have it written right here looks a little different? The probability that z is greater than, remember, z greater than represents this. This right here, the probability that it is that orange area. This part here, which I actually calculated, that is that line right there. So we want to know what's above that line. Well, I found out what's below that line, and then I subtracted it from 1. Now, I'm going to show you a trick. Calculator time. Also, instructions in your book. So, here's a reason why I write it like this. just like this, because if I do this, you get full credit, and then you can put your answer and you're done. You don't have to write this, because those two are the same thing and they know you're talking about a z-score. So I'm kind of adding it in one step, and if you learn how to use your calculator, you're going to actually be able to use it a little bit better. So here we go. Let me see here. I'm going to go through this once, and then we'll do it in class also. So new area where you're going to go. You're going to go second, distribution. It comes up with all these pieces here. You're going to go to normal CDF, which is number 2, normal distribution. We're going to hit enter. Your lower boundary, upper boundary, your mean, and your standard deviation. So let's look at this here. So we're going to look at the pieces here. We know my lower boundary of the shaded area. So we're talking about the shaded area. My lower boundary of the shaded area, I'll just do it side by side here. My lower boundary of the shaded area is 120. My upper boundary, you're going to want to make it a lot larger, so we use 999. Just go way above whatever value you're dealing with. My X bar is 115, and my standard deviation is 6. Enter all the way down to here. Hit enter. It will spit out this type of looking setup. Hit enter one more time, and lo and behold, it's 0.2023, 0.2005. There's going to be a little bit of a difference because look how many decimal places the calculator goes to, and your table only goes to 4. So this is close enough as long as you use the concept right. So we're able to do this on our calculator. So let's go ahead and go to this one. So if I go, let me back out just a little bit here. If I look at this, we want the percent of Nadal's serves between 100 and 110 miles an hour. So my lower boundary is 100. My upper boundary is 110. My X bar is 115. And my standard deviation is 6. Okay, so let's go ahead and do the same thing. Second, distribution, normal CDF, lower boundary, what'd I say? 100. Upper boundary, 110. Standard deviation and mu stay the same. Enter, enter. 0.1916. I got 0.1917. So what I'm trying to explain to you guys is if you write it like that and use your calculator and put an equal sign right here and put 19.71%, with this drawing, all this work disappears. That literally tells me you know what you're doing. So start gradually learning how to use the calculator. They don't care if you use the calculator or the table. I will always show you both, because if your calculator goes dead, you're going to have to be able to learn to use this. So some people actually prefer this, and they don't hardly use the calculator at all during the test. So there's that one. So let's go through all these different ones here. So the fastest 30%. So again, if it's 30%, well, the area we're looking for is 70. So we would go to our 70%, and we're right here. Our 70% is right here, which is a z-score of 0.53, 0.52 in there somewhere. And then we would work with it that way, okay? So we'd go 0.53. Now, you can actually do this, what's called inverse norm. So here we go. Let's try it again. Back to second, distribution. I haven't done this in a while, so this could be totally wrong. We're going to find out. Inverse norm, enter. We're going to go with the area we want, which is 0.7000. We're going to go with the mu that we have, which is 115. We're going to go with our standard deviation, which is 6. And we'll just go ahead. We can do the left or the right because I used 0.7. You could use 0.3 in the calculator. If I hit enter and I go to the left, I get 118.14. I get 118.18 using this method here. So you can calculate it by hand. You can draw it. You can use your calculator, and you can figure it out from there. So there's a couple of different ways to do it. All right. IQR, same thing. We can find our upper and our lower, plug in our z-scores, and then we can find it from there. So I'll let you guys look at that one. As you guys go through this, I'll let you guys use your calculator for these just to kind of double check to make sure that you're getting them right. And remember, lower boundary, upper boundary. Okay, this is our X bar, but in your calculator it may say mu, and then we got to make sure we use our standard deviation right there. All right, the other trick that I got, so it didn't show up, but I'm gonna draw it right here, just so you guys know. For a calculator, if you have it shaded to the left, this will be your upper boundary, and your lower boundary will be something like -9999 or something like that, okay? So your lower boundary, when it's shaded to the left, is just a -999. When it's shaded to the right, your upper boundary is 9999. It doesn't matter as long as it's 900. I always do like 3 or 4, just to make sure it's big enough to get it way out of the way. So that's your plan. Guys, hopefully the video is a lot shorter than it was before. It's 21 minutes, and I got through the whole video. Last time I only got to like a page and a half before this. Have a good one, guys. We'll see you soon.